Alright, this is a quick explanation of Parachute Man. For those of you either that were absent or having a hard time understanding, I'm going to give you a visual here. So, how Parachute Man works is we start with a story. We've got a guy jumping out of a plane. This works when you see this triangle like we have here. This triangle like we have here, where there's two right angles. A right angle here and a right angle down there. And we have a guy jumping out of a plane. And the rule is one of the sides that is labeled coming down is the side that he's going to fall down. So our first demonstration, just to kind of get an idea of how the story goes, is I'm going to tell you which one he's falling down, but when you look at a problem, the numbers in the problem will tell you what he's falling down. So the first thing we're going to do is we're going to say he falls down CA here. So if he falls down CA, we want to be able to set up the proportion correctly. So the first thing you have to know is how to set up the proportion. So the rule is whatever distance he's falling actually goes across from each other, and you use it twice. So that would be, in this case, that side CA. And I'll give you an example with numbers in a second. If he falls down that side, he's going to land right here where I put that star. So here he is, he's falling down that side. So he falls down, he lands on the ground. The rest of the story says that the other two lines that he didn't fall down turn into ladders for him to get back up. So he can walk to here to get to a ladder to get back up, and that's actually the next thing that's going to go in the proportion, the distance he walks, number 1. So that would be from A to D. Or the other side also turns into a ladder for him to get back up. So this turns into a ladder here. And that's the distance he can walk, number 2. So that would be from A all the way across to B. So that's kind of how the story goes, is he falls down. So that's how the story goes. He falls down a side, and he can walk this side to go up the ladder, or he can walk all the way across to go up the ladder. So now we're going to look at some with some letters and numbers to make it a little bit easier, but this is just to kind of give you an idea of how the story goes. So here's what your problems are going to look like. We're just going to kind of walk through how you would set these up in terms of the proportion based on the story. So again, remember the setup is the distance he walks, number 1, over the distance he falls equals the distance he falls. That's always going to be across from each other, diagonal from each other, over the distance he can walk, number 2. Those will be two different numbers for walk number 1 and walk number 2. So looking at Parachute Guy, he's up there at the top of that right angle. He can only fall down one of the sides. How you're going to know which side he's going to fall down is whichever one's labeled. So since this one has something labeled on it, we know he's going to fall down that side. So that is the first thing we would fill in the proportion. It's going to go across from each other here. A and A go there. And then he lands right here. And now he can walk to this first line. That first line turns into a ladder. And he can walk back up, so that's where you have to start calculating how far did he walk. He walked 7. Now that we have numbers, we can talk about it. Or he can go back to where he started, and he can walk all the way to the other side to get to a ladder. So this turns into a ladder, but this is where you have to be careful, because he started at the star, and he's walking all the way across. To calculate that, since he's going the whole distance, you have to add them together. So that would be 9. In the notes, we'll see how to solve these, but I just wanted to show you the setup. So let's look at the next one. So for this next problem, I'm going to put him up here. He's going to start at the top. You again have to look at what of these 3 lines coming down, which one's labeled, to decide where he's going to fall. And he's going to fall down X here. So if he falls down X, he's going to land right here. I like to put a little star there. So that means the X is going to go across from each other in our proportion. And then we have to figure out where he can walk to get to a ladder. He can walk to the first line. That's going to turn into a ladder. which is a distance of 9. Or, this is where you got to be careful, or he can walk all the way across here. And if he walks all the way across, this is again where you have to be careful, is you have to calculate how far that distance is from where he landed the star to all the way across to get to the second letter. So that's going to be 12. So anytime he falls on that outside edge, you really have to be careful because you're going to have to add them together. Now let's look at number 3. If he's standing up here, or flying up there, parachuting up there, of those 3 lines that come down, there's only one that's labeled. The one that's labeled is this B side. So that's where he's going to have to fall. He's going to have to fall down B. And he's going to land here. So now he's falling down the middle. These are actually, in my opinion, easier problems. Because once he lands down here, he can either go to the left to get to a ladder, that turns into a ladder, which would be 8. Or if we go back to where he landed, he can go to the right to get to a ladder. So he's going to the right then to get to the ladder. And that distance is 4. So in my opinion, those are easier because you don't have to do any adding. He either goes left or he goes right, no adding or subtracting. So hopefully that will help you. If you want to take a minute to try and set up number 4, you can pause the video, try and see if you can figure out how to set up number 4, and I'm going to set it up in 5, 4, 3, 2, 1. So first part of number 4 is he's falling down this side because it's the only one that's labeled. He'd fall down Y. He'd land right here. And then he can walk to the first line to get to a ladder, which is 5. Or, since he's on the outside edge, he can walk all the way across to get to a ladder. You have to think where he landed, where he's getting to. All the way across to get to a ladder would be 11. So that would be the setup for that problem. Hopefully this helps. The notes show you how you have to solve from there. But we'll be going over this again on Monday.